This is an alkaline hydrogen fuel cell. Hydrogen and oxygen are reacting to form water, but with all electrochemical cells, the oxidation and reduction half reactions have been separated, and electrons from the oxidation half cell are forced to flow around an external circuit, doing work, driving our motor or lighting our lamp, before they reach the reduction half cell. Let's have a look at this in a little bit more detail. We have got our hydrogen and our oxygen being pumped in at opposite sides of the cell. They're separated by both electrodes, so we have an anode and we have a cathode, and the anode and the cathode are separated by a region of electrolyte. And the electrolyte in this cell is a concentrated solution of potassium or sodium hydroxide. And that is going to allow hydroxide ions to flow from the reduction half cell to the oxidation half cell, as we will see in a minute. The anode and the cathode are both composed of porous carbon impregnated with a catalyst. And the catalysts vary depending on the design of the fuel cell, but it's quite common for the catalyst in the cathode to be nickel-based and that in the anode to be platinum-based. So that's going to aid the oxidation and reduction of hydrogen and oxygen, respectively. Let's have a look at the reactions that are happening. At the anode, we have an oxidation reaction, and it's the oxidation of hydrogen gas. We can see that that's being pumped in at the top of the cell. Hydrogen gas reacts with hydroxide ions to form water plus electrons. So loss of electrons is oxidation. The electrons, as we can see, are going to flow up through the anode, which we know is made of porous carbon, graphite based, with the platinum catalyst inside, so that's going to conduct and around the external circuit. These electrons are going to come back to the cathode. At the cathode we are going to have our reduction reaction, and it's the reduction of oxygen, so half O2 plus water plus 2 electrons going to form 2 hydroxide ions. And these hydroxide ions then pass through the electrolyte to the oxidation half cell, where they are used in the oxidation of hydrogen. It's kind of ingenious, isn't it? If we have a look at the electrode potentials, the standard electrode potential for the oxidation half cell is minus 0.83 volts, and for the reduction half cell it is plus 0.40 volts. So we can see that standard electrode potential of the hydrogen half cell is less positive, so it's going to release electrons compared with the cathode. The acid hydrogen fuel cell works in essentially exactly the same way. We just have different half reactions and a different electrolyte. So we can assume that the anode and the cathode are similar construction. So we're talking powdered carbon graphite, electrode impregnated with platinum, nickel, or maybe some other metal catalyst. In the acid hydrogen fuel cell, the electrolyte is phosphoric acid. So phosphoric acid electrolyte, which allows the flow of hydrogen ions from the oxidation half cell to the reduction half cell. So let's have a look at the reactions happening in this cell. At the anode, once again, we have oxidation, hydrogen gas loses electrons to form hydrogen ions, and the standard electrode potential, of course, for this half cell is by convention 0 volts. And at the cathode we have reduction of oxygen, so we have half O2 reacting with those hydrogen ions So these hydrogen ions here are going to flow from the oxidation to the reduction half cells through this phosphoric acid electrolyte, plus 2E minus, going to form H2O. And the standard electrode potential for this is plus 1.23 volts. So, as you can see, in both cases we have got oxidation of hydrogen, reduction of oxygen. The product in each case is water. And it's just a really clever way of harnessing the energy from this reaction. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the blurb below, it will take you straight to the Crunch Chemistry School, where you'll find all the resources you need to get that A-star grade at A-level. Together we can do this.